Hello guys, I'm GT. Let's continue with numerical integration part 5, Simpson's 3-8 rule today. So as you can see here, this is Simpson's 3-8 rule. And basically it's using a third degree polynomial to approximate area under curve. And it is exact for first degree, second and third degree polynomial. Okay? So if you got a function y in terms of x, which is y equals to fx, and you want to find its area under curve, and it is hard to integrate this fx. So what you can do is you can use gx as a b to approximate the area under curve, and this approximation is by using a third degree polynomial. Okay, so you cut the area into 3 pieces, and these pieces we are called subinterval. This number of subinterval is called n, and it has equal length, which is delta x. Okay, so delta x, we can use the boundary, which is b minus a divided by how many segments, okay, how many subintervals. So it is b minus a over n, and this n can be 3, 6, 9 and 12. It can only be multiple of 3, okay? But today, since we are not going to do the composite Simpson's 3-8 rule, just need to remember that n is 3, okay? So let's move on. So what is area under curve? The approximate area under curve is given by 3 over 8 times with delta x, and then this is 1, 3, 3, 1 of the function. Okay, as you can see here, you have cut everything into these segments, right? And then this is delta x, delta x, delta x. So this is a plus delta x, this is a plus 2 delta x. Okay, so you just plug in here a plus delta x, a plus 2 delta x, and b, and then you just need to remember the magic number for today, 1, 3, 3, 1. Okay, so basically we just plug in this formula to find the approximate area under curve. Why do we do so? It is when this function is hard to integrate. Okay, so let's move on to one example. If you are given this function and you are asked to find the area under curve, find it using Simpson's 3-8 rule. Okay, so first thing, you're gonna determine the fx. Fx is this, and then you got to find delta x. Delta x is b minus a divided by n. Since today we are not doing a composite one, let's just assume it as 3. Okay, so now you just plug in the formula, 3 over 8 times with delta x. Okay, so this is a plus delta x, this is a plus 2 delta x, and this is b, 1, 3, 3, 1. Okay, so solve this, plug this into the function of x cubed plus 1, you got this. So press your calculator, you got 6. And let's see if this is exact, as this is a polynomial of third degree. Okay, the highest index is 3. So you solve it by using normal integration, you got the answer 6 as well. So we can conclude that Simpson's 3-8 rule is exact when it is first, second, third degree. Okay, so next let's move on to another example. This is where it is hard to integrate, right? So if you got this kind of integration, although it can be integrated, okay, but it is harder than the previous one. Okay, and if you don't know how to integrate this in order to get the area under curve, you can just use Simpson's 3-8 rule. Okay, since it's an approximate area under curve, so you just determine the delta x As you can see, the boundaries are 1 and 0. So you just plug in and then divided by 3. So you got the delta x. Okay, so as usual, 3 over 8 times with delta x. So this is a plus delta x, a plus 2 delta x, b, and 1, 3, 3, 1. So now you just plug in this fx, square root sine cube x plus 1 in using these values. And then press your calculator, you got 1, 1.0174, 1.1120, 1.2633. And then press your calculator, you got this is approximately equals to this. Thank you for watching. Hit the subscribe button if you would like to see more videos about math and engineering. See you guys next time.